Hello, back here with another section of notes, 4.2, solving quadratic equations by factoring. In 4.1, we looked at quadratic equations but solved them by graphing and looking at tables. Today, we're going to use our old friend factoring, which is why we've been practicing. So we have been working on rewriting expressions. All right, where I have things written, for example, 2x squared minus x minus 3. That's an expression, not an equation. Today we're going to talk about equations. When we've been talking about expressions previously, we would rewrite this as a product of its linear factors. Okay, so the equivalent statement would be x squared minus 3, quantity squared times x minus 1. Those are the same. They have the same. They're equivalent. So we're going to start off really simple, but the first thing we're going to do is we're going to use what we know about factoring to solve quadratic equations. This first example here is already factored for us, so kind of cheating and like skipping the first two steps. So solve the equation. What we're going to do is I have some number times some number is equal to 0. The only way I can have that be true is that one of these has to be 0, or both of them. So what I'm going to do here is I'm going to take each factor, 2x minus 3, and I'm going to set 2x minus 3 equal to 0. And then I'm going to take the other factor and set x plus 1 equal to 0. Remember, this is taking the product, so I'm multiplying. Something times something equals 0. Again, the only way I can have that is if one or both of these factors are 0. So I can essentially take each factor, each piece, set it equal to 0, take the next piece, set it equal to 0. And then I'm going to solve these two mini equations. Okay, so 2x minus 3 equals 0. I'm going to add 3 to both sides. And then to get x by itself, I have 2 times x. The inverse operation of multiplication is division, so I divide by 2, and I get x is equal to 3 halves. I'm going to take this over here and just scoot it over a little bit. X plus 1 equals 0. I'm solving for x, so I have to move the 1. How do I do that? I subtract it from both sides. Okay, so I get two values of x. So I get x is equal to negative 1 and x is equal to 3 halves. That's going to fall into these brackets over here, and the assignment goes back and forth between using the solution set and these brackets and x equals. So just to show you that they're the exact same thing, I'm going to do both of them here. So you could say the solution set is fancy parentheses negative 1 and 3 halves, or we could just say x is equal to negative 1 and 3 halves. Just know that they're the same thing. So regardless of how they ask for you to fill in the blank, right? However they're asking for their answer, it's the same thing. So that means that this original equation, A, is true if I plug in negative 1, all right, then I get 0. And if I plug in 3 halves, then I get 0. Any other number is not going to give me 0. So let's talk about the differences between what I just did here in example 1a and what we did above. But above, all we did was factor and rewrite an expression. All right, so I can't emphasize this word enough, expression. These are equations, which means they can be solved. Solving, like we discussed in 4.1, is finding the value of the variable. Okay, so I can solve an equation. I cannot solve an expression. That's not a thing. Okay? So let's write out a formal definition of the zero product property. The zero product property says that for all real numbers, A and B. If A times B equals 0, then A is 0 and or B is 0. The zero product property says that for all real numbers, if A times B is equal to 0, then A is 0 and or B is 0. This property is what allows us to set these pieces equal to 0. So again, this is just small pieces of the work. We're building up. What I would like you to do for problem B is it's already factored for you. So it took out the hard part. And what I want you to do is I want you to take each factor, set each factor equal to 0, and solve for the value of x. So go ahead and pause this video, set x minus 4 equal to 0, find x. Set 3x plus 8 equal to 0, and find x. Find x. Okay, so we're back. Hopefully you took a moment to do this on your own. So I'm going to set x minus 4 equal to 0. And to solve for x, I'm going to add 4 to both sides, and I get x is 4. If the other factor, 3x plus 8, I set that piece equal to 0. Subtract 8 from both sides. Then divide by 3. And if that solving is a little fast for you, just slow it down. Watch it again. You can change the speed of the video. And now I can write this in two different ways. It is acceptable to write x equals negative 8 over 3, 4. It is also acceptable to write the solution set equals 8/3, 4. Again, on the homework, it's going to ask for the solution set for this specific problem, but just know that they are the same. So the objective of example 1 is to use the zero product property because that's likely new to us. In example 2, we're going to put all the pieces together. So that's my note there. It says, this is the real work. Here we go. Are you ready? So I've got an equation, and I'm going to solve the equation by factoring. The steps are overwritten in purple here. Step 1, I need to rearrange this equation and solve it for 0 first. So what that's talking about is look at A compared to B and C. A is already solved for 0. B is equal to 64 and C is equal to 4. So those are not solved for 0. So I have to do some rearranging on those. Okay. All right. Step 2, factor. Now, when I factor, the first thing I'm going to do is I'm going to look for the GCF, and then I'm going to rely on my box method. So if you printed these notes, I have a little addition in red here. Look for GCF first. That's just a little reminder. Step 3, I'm going to use the zero product property like I did above in example 1, and then solve to find the value of the variable. Or technically, I guess I could have apostrophe S here because I could have variables. Okay. Here we go. Step 1. Solve the equation for 0. So for A, it's already equal 0. So I don't have to do step 1. Step 2 is to factor. So I'm going to take this expression, right? I'm going to take half of the equation, this part, and I'm going to factor it. So I look for the GCF first. Is there anything I could take out of all 3 terms? No. Then I do product sum. So I multiply A times C. So 1 times 36. I'm looking for 2 numbers that multiply to 36 and add to 12. So if I write out a list of everything that multiplies to 36, I get this list. And I'm looking for things that add to 12 or subtract to 12. And my answer is going to be the 6 and the 6. So I rewrite. I split this middle term up. And I get x squared plus 6x plus 6x plus 36. And then I'm going to do my factor box with that. So I write all 4 terms in my box, and then I'm going to look for what I can take out of each column and each row. X squared plus 6x, I could take an x out. 6x plus 36, I could take a plus 6 out. My first column, my first row, x squared plus 6x, I could take an x out. 6x plus 36, I can take a plus 6 out. So when I rewrite this expression in factored form, I have x plus 6 times x plus 6. Now I know all of that is equal to 0 when I plug it back into my equation. So the point of factoring is just to rewrite an expression as a product of smaller pieces. Linear pieces if you can get it, linear factors if you can get it. All right, so that's all practice factoring. Now I'm going to use the zero product property where I take each factor and I set it equal to 0. Solve for x. So now I just did step 3, use the zero product property. And then step 4, solve to find the value of the variable. So now I'm going to solve for x. And I get x equals negative 6. And I get it again. Now, while that affects the way that the graph looks because it occurs more than once, my answer is just going to be a very simple x equals negative 6. That means that it's going to touch at negative 6 and turn around and go back the other direction, right? We looked at graphs that only had one solution. This is one of the huge essential learnings of this course. So the reason why factoring is important is so we can solve quadratic equations by factoring. I'm going to go out of order. I'm going to have you do B, but not for a couple of moments because I'm going to do C with you. So we're going to work on C together first. Problem C. If I look back at my steps, solve the equation for 0. I have 3x squared plus 4x equals 4. I don't have equals 0. So I need to rearrange problem C so that I do have equals 0. So the easiest way to do this, and there's more than one right way, the easiest way to do this is I'm going to move the 4 because I want this to equal 0, so I'm going to subtract it from one side and subtract it from the other. When I do 4 minus 4, I get 0. When I subtract it from the left-hand side, I'm going to have 3y squared plus 4y, and this is not a like term, so I'm just going to tack it on at the end. Now it looks like problem A. So I solved the equation for 0. I did the first step. Second step is to factor the expression. So I have 3y squared plus 4y minus 4. I'm going to factor this side. 3 times negative 4 is negative 12 with a sum of 4. So what things multiply to negative 12 and add to 4? Okay. Hopefully you'll find that 2 and 6 work. So that's how I'm going to split up my middle term. So I have 3y squared. Now I need a positive 4y. So if I'm playing with 2 and 6, in order to get a positive 4y, I need the 6 to be positive and the 2 to be negative. So minus 2y plus 6y minus 4. And you'll notice that I'm just writing the expression for now. That's okay. I'm going to go back and write it as an equation later. Three y squared minus 2y plus 6y minus 4. I'm going to encourage you to pause this and try to work this out from here. See if you can do 1 or 2 steps on your own. Otherwise, when I start factoring myself, I like to look at the first column first, 3y squared plus 6y. I can take out a 3, I can take out a y. Minus 2y, ooh, I made an error. Did you catch that? There shouldn't be a squared on the y. Okay. So now here I have minus 2y minus 4. When I factor a number out, because the first term is negative, I factor out a minus 2. All right. Now my first row, 3y squared minus 2y gives me a y. 6y minus 4 gives me a 2. Okay, so my expressions are now 3y minus 2 times parentheses y plus 2. Now it's an equation, so it's all equal to 0. All right, so we solved the equation for 0. We factored. Now I'm going to use the zero product property. I'm going to set each one of these factors equal to 0. Because I know something times something equals 0, then one of these must be 0. And then solve. Three y minus 2 equals 0. So to solve for y, the first thing I have to do is add 2. And then to get y by itself, I divide by 3. Whew, I'm a little squished on this problem. Needed a little bit more room. So for my answers, I've got y is equal to negative 2 comma 2/3. All right, and those values of y, -2 and +2/3, those are the values that will make this equation for problem C true. All right, so for problem B, I'd like you to go ahead and try to do that one on your own to the best of your ability before we do it together. So pause this, give it a shot, do the best that you can, follow through those steps. Okay, now as we return together, the first step is to solve for 0. So to do that, I'm going to subtract 64 from both sides. So I get n squared minus 12n minus 64 is equal to 0. Then I move ahead with my factoring. When I start to factor, I always multiply a times c. So the number in front of x squared times the constant, I get 64. So now I'm looking for numbers that multiply to 64 and add to 12. So when I look at this list, and if I'm going too fast, please slow this down or pause it. When I look at this list, I get 4 and 16. So now I rewrite my middle term so that I've got n squared. In order to get a minus 12, I'm going to need a positive 4n and a minus 16n. Then I write that in my box. N squared plus 4n minus 16n minus 64. And I look for my GCFs, right? My greatest common factors in each column and each row. N squared minus 16n, I can take out an n. Plus 4n minus 64, I can take out a 4. N squared plus 4n, I can take out an n. And then on the bottom, minus 16n minus 64, make sure you take out a negative 16. So when I rewrite this, n plus 4 times n minus 16 equals 0. I'm going to put that up here because I need a little bit of room. Now I can take each factor, right? Step 3 is that I'm going to use the zero product property and set each factor equal to 0. And I get n equals -4. And n equals 16. So those are going to be my answers. Those are the numbers that make the original equation true. Okay, that's really the biggest piece of what we're going to do today. So if you're not ready to move on to example 3, please take some time and review, maybe rewatch this section or just rewatch one of the problems from example 2 before we build on this even further. And when you're ready to move on, I'll invite you to look at example 3, which brings some different ideas all together. Example 3, factor. Find the coordinates of the vertex of the related function, then graph. So I'm going to do a couple of things here. Above, when I find these values, like for example 2b, when I get n is equal to -4 and 16, those are the values of n. That's how I solve the equation. Remember that that's very closely related to my intercepts. I'm going to use that to my advantage on example 3. I'm not going to use any graphing functions on Desmos or anything like that for this. We're just going to do it by hand. So here we go. Step 1, factor. When I'm factoring this, just like the steps above, I've got to have equals 0, right? So it's already solved for 0, so I'm good there. All right, next. I'm going to go through the steps of factoring. So 1 times -8 and -2. What numbers multiply to -8 and add to 2? Well, there's not a lot that multiplies to 8. Okay, so I rewrite that middle term. I get x squared. Whoa. To get a -2, I'm going to have a plus 2x and a minus 4x. It's my greatest hope that this is starting to become a little easier as I factor over and over and over again. Okay. So I'm going to use my factoring tool here. All right, what can I take out of each column? X squared minus 4x. I can take out an x. My next column, I can take out a 2. First row, I can take out an x. Second row, my leading term is negative, so I have to take out a -4. So now I've got x plus 2 times x minus 4 equals 0. And you're like, so what? What does factoring have to do with graphing? Well, now that I have this in factored form, I can use my zero product property, which says I take each factor and set it equal to 0. That's going to give me my x values, which are my x-intercepts. So watch this. So I solve for x. I get x equals -2. And x equals 4. So I go to my graph, and I go to -2, and I make a dot. And I go to x equals 4, and I make a dot, because those are the solutions. That is x, which can give me my x-intercepts. Now, that's not enough to graph a parabola, because I don't know how narrow or how wide this is. So the other piece of information would be found by finding the coordinate of the vertex. Oh, you have to dig way back in your memory on how to find a vertex in standard form. And the equation for finding a vertex in standard form is x equals -b over 2a. If you find it helpful, you can write the standard form here right above or below the equation. So -b. b is -2. So when I take the opposite of that, I actually get +2. Divided by 2 times 8, which is 1. 2 divided by 2 just gives me 1, so x is 1. Great. Do you remember what that's for? It's for the axis of symmetry. Yes. If you wanted to, you could draw it in. It doesn't ask for it, so I don't have to, but I could draw it in if I wanted to. There's my axis of symmetry. Hey. Then how do I find the y value? Right? So now I'm going to take x equals -1, and I'm going to plug it back in. So my original equation is x squared minus 2 times x minus 8 equals 0. Instead of x, I'm going to plug in 1. 1 squared is 1. Minus 2 times 1. Minus 8 equals 0. 1 minus 2 minus 8 is actually -9. So I get this point 1, -9. And from there, I've got enough information to actually graph this quadratic. It's still not going to be perfect because I don't know all the points that I hit, but it's going to be good enough. All right, that's kind of a lot of steps. So I'm going to recap what I did in just a moment. Okay, so to recap, first thing I wanted to do was factor and find the values of x. So everything here was just a reminder of what I just did above. What I did over here in purple was a reminder of finding the vertex in standard form. So if you're looking for help on that, that's going to be from 3.3. All right. Problem B, much the same. Little difference here because I only have 2 terms in my equation instead of 3. Still going to factor. So first thing first, hopefully you'll notice that it is solved for 0. Yes, step 1 is done. When I'm talking about step 1, I'm talking about these right over here, right? These steps. Okay. So next thing I'm going to do is I'm going to factor. Well, having 2 terms, I've got an x squared term and a constant. Oof, we got to dig around in our memory. Remember when I'm missing that middle term, I would write it in. I'd write in a 0x term in there. And that's your key to this, why this problem isn't really any different from the other one. Okay. So I multiply 1 times -9, I get -9. What 2 numbers multiply to -9 and add to 0? Remember, the only time they can add to 0 is when they're the same number but opposites. So when I split this term up, I get x squared minus 3x plus 3x minus 9. Right in the box. Take out all the GCFs from each set of columns and each set of rows. X squared plus 3x, I can take out an x. Minus 3x minus 9, I'm going to take out a minus 3. First row, x squared minus 3x, I can take out an x. Next row, 3x minus 9, I can take out a 3. So this factors to x plus 3 times x minus 3, all is equal to 0. The 0 product property says each one of these is equal to 0. So x plus 3 could be 0, or x minus 3 could be 0. Which in turn, when I subtract 3 from both sides here, I get x equals -3. And when I add 3 to both sides here, I get x equals +3. What information does that give me for my graph? Those are the x values of the intercepts. So I go to the x value and I put a dot at -3 and dot at +3. These are points on the graph. Yes. But I still need the vertex. In order to get the vertex, I'm going to use x equals -b divided by 2a. If you feel like it's helpful, you could write standard form of the equation. So when I plug in x equals -0 divided by 2 times 1. Well, 0 divided by anything is just 0. So I get x equals 0 for my x value of my vertex. You could draw in the axis of symmetry if it makes you happy. And then I'm going to plug x equals 0 in to my original equation. So my original equation is x squared minus 9 equals 0. What's x? 0. 0 squared is 0. I'm sorry, I keep putting equals 0 at the end, and I shouldn't be. I should just be evaluating the function on the left-hand side. And I get -9. So I have 0, -9. as my vertex, and I've got these 2 points, negative 3, 0, and 3, 0, to intersect, and I get a graph. Okay, those were not my most flawless notes, but hopefully you were able to follow along well, and they will help inform you on how to solve quadratic equations by factoring. Thank you very much. Have a great day.